Hi, Assalamualaikum and a very good morning everyone. So in today's video, we are going to continue with the chapter 5.2 Hydrocarbon Alkene part C. So in this part C, we are going to look into the reactions of alkene. So let's see the learning outcome for this part. Okay, at the end of the lesson, students should be able to explain the addition reactions of alkene with hydrogen in the presence of catalyst, or we call it catalytic hydrogenation. Second one is the reaction of alkene with halogen in inert solvent. Third one is the reaction of alkene with halogen in water. Fourth one is the reaction of alkene with hydrogen halide, or this is called hydrohalogenation. And last one is the reaction of alkene with acidified water. Alright, and then we are going to write the mechanism of the electrophilic addition of hydrogen halide with HCl or HBr, as well as the reaction with acidified water, and explain the formation of product according to the Markovnikov's rule. And last but not least, we are going to determine the product of the reaction between alkene and the hydrogen bromide HBr in the presence of peroxide, which is ROOR, according to anti-Markovnikov rule. Okay, so the peroxide here can be the hydrogen peroxide or the metal peroxide like CH3OOCH3. Okay, so if we see the HBr in the presence of peroxide, so the reaction will follow the anti-Markovnikov rule. Okay, now without further ado, let's get started. Alright, so in contrast with the reaction of alkene, so the most important reaction of alkene are the addition reaction to the double bond. So addition reaction is a reaction in which an unsaturated molecule becomes saturated molecule by the addition of a molecule across the multiple bond. So in this case, in the double bond. Okay, so let's see the criteria ataupun the characteristic of the addition reaction to the double bond. So they have three characteristics. First one is that the pi bond of the double bond is broken and the two new single bonds are formed. So for example, here we have C double bond C here. So when we undergo addition reaction, the pi bond here will be broken to form two new single bond here. Okay, next, second one is only one product is obtained at the end of the reaction. Alright, and the last characteristic is that the product obtained is the saturated organic compound. Okay, such as maybe alkane, maybe alcohol, or maybe haloalkane, but the product is a saturated organic compound. Alright, now let's look at the reactions of alkenes which involve the addition reaction to the double bond. So let's look at the first reaction of alkene, which is the catalytic hydrogenation. So what is meant by hydrogenation? So it is the addition of hydrogen, alright, to a double bond or triple bond to yield a saturated product. So in this case, for catalytic hydrogenation, we will form an alkane. Alright, so alkene and hydrogen, it will not react under normal conditions, but it can combine with hydrogen in the presence of catalyst to form an alkane. So in this case, the most used catalyst for the hydrogenation is platinum or palladium. Alright, so let's look at this reaction. We have this alkene here. So the pi bond of the double bond will be broken to form two new single bond here. So and each of the two new single bond here will be bonded to the hydrogen atom from the hydrogen molecule to form a saturated product of alkene. Alright, now let's look at the second addition reaction of alkene, which is the addition of halogens in inert solvent, or we call it halogenation reaction. Alright, so unlike alkenes can react with halogens at room temperature and even in the dark. So the halogen is usually dissolved in an inert solvent such as dichloromethane CH2Cl2 or CCl4. So the example of halogen used is usually chlorine or bromine. So chlorine and bromine will react readily with alkene in the liquid or vapor states to form the addition products dichloroalkane or dibromoalkanes respectively. Alright, so here for example, here we have alkene and the bromine molecule. So the pi bond of the double bond will be broken to form two new single bonds here, and the bromine atom will each bonded to the new single bond form to form dibromoalkane, which is the saturated product. Same here, we have this cycloalkene here. So the double bond of the cycloalkene will be broken to form two new single bonds here, and each of the bromine atom from the bromine molecule will be bonded each to the two new single bond form to form dibromocycloalkane, which is also the saturated product. So the reaction between the bromine or chlorine with alkene is called an electrophilic addition because the bromine and the chlorine molecule is an electrophilic reagent and it is added to the double bond during the reaction. Alright, so for bromine, it has the reddish brown color. So upon reaction with alkene, the color of the bromine will be decolorized. Alright, so before we proceed to the rest of the addition reactions of alkenes, we're going to look into the Markovkov rule. So what is Markovkov rule? So Markovkov rule states that in the addition of reagent to the unsymmetrical alkene, the more electropositive reagent will be added to the carbon atom of the double bond with the larger number of hydrogen atoms. So this rule is applicable to the addition of reagent which involves hydrogen halide, contohnya macam HBr or HCl, okay, and the reaction of alkene with acidified water because it involves two different species that is going to be added into the double bond. Okay, so for example, here we have this carbon-carbon double bond. So in this carbon, we have two hydrogen, right? In this part of carbon, it is bonded to one alkyl group and one hydrogen. So we can see here that this alkene here is the unsymmetrical alkene. Dia tak symmetry. Okay, sebab apa? This carbon dia bonded pada dua hydrogen. This carbon dia bonded pada satu alkyl group dan satu hydrogen. Okay, so let's see if we have hydrogen halide such as HBr or HCl, or maybe we have H2O in acidified water. Okay, so reaction of alkene in acidified water. So here we have two different species that is going to be bonded to the new single bond form after the pi bond broken, kan? Okay, so we have hydrogen here and Br here, we have H and Cl. So according to Markovkov rule, dia kata kat sini, so kalau kita ada unsymmetrical alkene, the more electropositive reagent will be added to the carbon atom yang ada larger number of hydrogen. So in this case, the more electropositive reagent in HBr is hydrogen. So hydrogen will be added to this carbon. Okay, so katakanlah kan, if we broke this double bond, so kita akan form two new single bond here. Okay, so hydrogen will be added to this carbon. Okay, and this bromine will be added to this carbon. So H kat sini, Br kat sini. Okay, same goes to HCl. So more electropositive is hydrogen. So hydrogen will be added to the carbon with more hydrogen, and Cl will be added to the next carbon. Okay, so for water in acidified condition, so we have OH and H, right? So H is more electropositive, so hydrogen will be added to the carbon with more hydrogen, which is this one, and the OH will be added to the next carbon. Alright, so this is what meant by the Markovkov rule. So the major product obtained is the one who follow Markovkov rule. So the product yang tak follow Markovkov rule tu, kita panggil dia minor product. Alright, so Now let's continue with the rest of the addition reaction of alkene. So now the third reaction of alkene is the addition of halogens in water. So still halogenation, but now in water. So the halogenation of an alkene is carried out in the aqueous solution, produce halo alcohol, or we call it halohydrin. So this reaction will follow Markovkov rule if the reaction involves unsymmetrical alkene. Okay, so in this case, this bromine is react with alkene in the presence of aqueous solution, which is water. So the species that will be added to the carbon-carbon double bond is bromine, one bromine and OH minus. Okay, so now upon the breaking of the pi bond, breaking of the pi bond here, it will form two new single bond here. Alright, so this alkene here is the unsymmetrical alkene, because if we look at here, this carbon here has two hydrogen. This part of the carbon double bond here has one alkyl and one hydrogen group. So this alkene is not symmetrical. Okay, so according to Markovkov rule earlier, we know that the more electropositive reagent will be added to the side of carbon-carbon double bond that has more hydrogen atom. So in this case, halogen here, bromine or chlorine, there are the more electropositive reagent compared to OH. So the halogen will be attached to the carbon with the greater number of hydrogen. So which means the bromine here will be added to this carbon, and the OH will be added to the carbon with less hydrogen, to form the halo alcohol saturated product. So this is the major product of the reaction. Let's look at another example of the halogenation reaction in water. So here we have chlorine. So the addition of chlorine in aqueous solution water in the double bond alkene. So now this double bond will be this pi bond of the double bond will be broken to form two new single bond here. So now the species that will be added to the two new single bond will be chlorine as well as OH. So since halogen is more electropositive reagent compared to OH, so chlorine will be bonded to the carbon of the double bond that has more hydrogen. So in this case, this side of carbon double bond has one hydrogen, while this side of carbon double bond has no hydrogen. Hence, the Cl will be bonded to this carbon and the OH will be bonded to this carbon to form this halo alcohol product. So this is the major product. So what if it follow the anti-Markovkov, so it will form the minor product lah, which the chlorine will be bonded here and the OH will be bonded here, dia terbalik. So major product dia mesti follow Markovkov rule. Now let's look into the fourth reaction of alkene, which is the addition of hydrogen halide, or we call it hydrohalogenation reaction. So it will form haloalkane. So this reaction also follow Markovnikov's rule, since it has two different species that are going to be added onto the double bond. So the reactivity of hydrogen halide to its alkenes increase in the order of this way. So the HF is less reactive to its alkene compared to HCl, compared to HBr and HI. So the hydrogen fluoride here has the less reactivity to its alkene, means that it reacts only with difficulties, while hydrogen bromide here can react very readily at room temperature with alkene. But for hydrogen chloride, it needs catalyst to react with alkene. So the catalyst that is usually used is aluminium chloride, AlCl3. Alright, so let's look here. We have this alkene here and we have HBr here. So this hydrogen bromide reacts readily with alkene to form the saturated product of haloalkene. So since this alkene is the symmetry alkene, so tak kisah which side pun H dengan Br tu nak attach. Okay, sebab dua-dua side ada dua hydrogen, so mana-mana pun boleh. So this is the product that will be formed. Okay, same goes to this alkene. So we have the addition of hydrogen chloride. So hydrogen chloride needs catalyst to react with alkene. So in this case, we have to put aluminium chloride. Okay, in this reaction. So this alkene is also symmetric. So it doesn't matter which side of the hydrogen or chlorine yang kita kena letak, yang kena bonded lah pada kita punya double bond tu, sebab this carbon, this alkene is symmetric. So what if the alkene is not symmetric? So kalau we have unsymmetrical alkene, then we have to use the Markovkov rule to determine the major and the minor product. So in this case here, we have this unsymmetrical alkene. So we have this carbon here with 2 hydrogen and this carbon here with only 1 hydrogen. So between H and Br here, the hydrogen is more electropositive. So the more electropositive reagent will be added to the side of the carbon double bond with more hydrogen. Alright, and the bromine will be added to the carbon with the fewer hydrogen to form the major haloalkene product here. So kalau dia tak follow Markovkov, dia akan follow minor product like this one. Okay, so untuk halogenation reaction, we have the reaction mechanism. So saya dah double star dekat sini. So double star means ada reaction mechanism. So now let's look into the reaction mechanisms of the hydrohalogenation reactions. So please bear in your mind that the characteristic reactions of alkene are electrophilic addition, which means that we are going to add an electrophile into the nucleophilic site. Okay, so the carbon-carbon double bond in the alkene molecule is known as the electron-rich part, which is the nucleophilic site. So the nucleophile will always attack the electrophile. Okay, so now for the reaction mechanisms of hydrohalogenation, it involves 2 steps. The first step is the formation of carbocation and halide ion, and the second step is the rapid reaction with negative ion nucleophile. Okay, so let's look at the first step. So we have this alkene here. So this alkene here will react with the HBr. So in the alkene, we have the nucleophile, which is the carbon-carbon double bond. So the nucleophile will attack the electrophilic site of the HBr. So the electrophilic site of the HBr is hydrogen lah. Okay, because hydrogen dia poor electron. Okay, so this carbon-carbon double bond will attack this electrophile, hydrogen. Okay, so bila dia attack this hydrogen, the single bond between H and Br will be heterotically broken. Okay, so both of the electron will be transferred to bromine to form bromine ion. And now the question is, when this carbon-carbon double bond attack this hydrogen, so where will the hydrogen be bonded to? This carbon or this carbon? So we have learned about the Markovkov rule. So the Markovkov rule states that the more electropositive reagent will be bonded to the carbon with more hydrogen. So hydrogen ni more electropositive kan, so dia akan attach pada carbon yang ini, sebab this carbon has more hydrogen compared to this carbon. So hydrogen ni akan form dekat sini dengan akan form bond dekat this carbon, and then this carbon now will be positively charged. Okay, so that's why we form this secondary carbocation and the bromine ion. Okay, now so this step here is a slow step. Okay, now we look into the second step, which is the rapid reaction with negative ion. So we have the carbocation here. So the carbocation here now is the electrophile. Okay, and then we have the bromine ion here. So the bromine ion here now is the nucleophile. So you have to always remember that the nucleophile will always attack the electrophile. So we have the nucleophile here, which is the anion, will attack the electrophilic site of the carbocation, which is this carbon. Okay, so this reaction is the rapid reaction. So the bromine will be bonded to the carbon here. So now we will get our major product of haloalkene that follows the Markovkov rule. Okay. finally, we're going to look into the last reactions of alkenes, which is the addition reaction with acidified water, H3O+, or we call it an acid-catalyzed hydration. So this reaction follows Markovnikov's rule. So we have this alkene, which is the asymmetrical alkene. So upon reaction with acidified water, it will form major and minor product, which the major product follows the Markovnikov rule. So the species that will be added to the double bond for this hydration reaction is the OH from the water and the H from the acid. Okay, so since the hydrogen is the most electropositive reagent, so it will be added to the side of the carbon of the double bond that has more hydrogen. So in this case, this carbon, and the OH will be bonded to this carbon, okay, to form the major alcohol product. Okay, and if it does not follow the Markovnikov rule, it will form the minor product. Alright, so this reaction also involve the reaction mechanism. So let's look into the steps of the reaction mechanisms for the acid-catalyzed hydration reaction. Okay, the first step is the protonation of the protonation to form the carbocation. Okay, so now here we know that the basic characteristic of the reaction of alkenes always the electrophilic addition. So it means that the electrophile will be added to the nucleophilic side of an alkene. So we know that the nucleophilic side of an alkene is the carbon-carbon double bond. So the D double bond, which is the nucleophile, will be attacking the hydrogen, which is the electrophile of the acid. Okay, so this nucleophile will be attacking this hydrogen. So the bond between the hydrogen and oxygen from the acid will be broken theoretically, alright, and both of the electron will be given to the oxygen here, alright, to form water. Alright, so now here this hydrogen will be bonded to the carbon with more hydrogen because it follows Markovnikov rule. So now this CH2 will become CH3, and this carbon here now will become positively charged. So this is the carbocation. It will form tertiary carbocation. Okay, so now after the formation of carbocation, we are going to look into the second step, which is the protonation, which is the formation of protonated alcohol. Okay, so kita nak form protonated alcohol, so we have our water molecule. Okay, so water molecule is our nucleophile. Okay, and this carbocation here is our electrophile. Alright, so nucleophile will be always attacking the electrophile. So the oxygen here is the part where it is the electron rich part. Okay, so this is the nucleophilic side. So the nucleophilic side will be attacking the electrophilic side of the carbon. Okay, so now they akan form the bond with the carbocation to form the protonated alcohol. Okay, so now we are going to look into the last step, which is the elimination of H+. So kita nak form alcohol, tapi kita punya alcohol ni dia ada lebih hydrogen. So kita nak buang satu hydrogen ni. So what we are going to do, we are going to use the water molecule. So the water molecule is the nucleophile. Okay, so it will attack the electrophile of the hydrogen. So bila dia attack this hydrogen, so the bond between oxygen and hydrogen here will be broken heterotically. Okay, so both of the electron will be transferred to this oxygen, and this hydrogen will be completely leaving the molecule. Alright, so now we form this alcohol and this H3O+. Okay, so this alcohol is 2-methyl 2-propanol. Okay, so these are the 3 steps for the reaction mechanisms for the acid-catalyzed hydration reactions of alkene. Alright, Now let's look into the reaction which follows anti-Markovnikov's rule. So when hydrogen bromide, HBr, is added to an alkene in the absence of peroxide, it will follow Markovnikov rule. But however, when the hydrogen bromide, HBr, reacts with an unsymmetrical alkene in the presence of peroxide, alright, which has this OO bond, okay, the hydrogen bromide acts in the opposite direction to that predicted by the Markovnikov rule. So they follow anti-Markovnikov manner, okay, which means that between H and Br, we know that hydrogen is more electropositive component, so it will so if it follows Markovnikov, it will bond it to the carbon that has more hydrogen, okay. But in this case, since HBr is added in the presence of peroxide, so the hydrogen atoms will be added to the carbon atom with the less number of hydrogen atom. So in this case here, we have this reaction of alkene with HBr in the presence of hydrogen peroxide. So the HBr will be added to this side of carbon, okay, and the bromine will be added to this side of carbon because it follows anti-Markovnikov rule. So this will be the product form, okay. So the next example here, we have this unsymmetrical alkene when react with HBr in the presence of peroxide, okay. So the H will be added to this carbon here, alright, because this carbon has less hydrogen, and then the Br will be bonded to this carbon, so it will form this haloalkene. Alright, and then this one too, we have this acid peroxide, okay. So this HBr, so this hydrogen will be bonded to this carbon here, and the bromine will be bonded to this carbon, so it will form this haloalkane that follows anti-Markovnikov rule, okay, because it has the presence of peroxide. So this only happens with HBr in the presence of peroxide only, either with hydrogen peroxide or acid peroxide, okay. So yeah, I think that's all for the part C of alkene. So we're going to meet in the next video, where we are going to look into the oxidation of alkene and the unsaturation test for alkene in part D and E of the video. Alright, so we'll see you again in the next video. Bye bye. Assalamualaikum.